Welcome to the demonstration of the Markoflow project. This demo accompanies a research project that will be presented at the BPM conference and that details the concepts behind the tool. The paper is available at meshart.org/markoflow/uiorchestration.pdf. This work is the result of the collaboration between the University of Trento and the Chinese telco company Huawei. The goal of the Markoflow project is to allow programmers to bring together web services, user interfaces and people into a single orchestration logic and tool. This is motivated from the fact that today every enterprise needs adequate instruments to design and run their internal processes, which normally include not only services but also people that interact with them through some user interface. Here we have an example of an application with similar requirements that we took from the Home Assistance domain. In this case, we have a process with two different actors involved, an operator and an assistant. The operator reaches a request from a patient, checks the patient profile, and sends instruction to the assistant that will physically go to visit the patient. When the visit is completed, the assistant compiles a visit report that is archived and then processed in the backend. If the report states that further exams are needed, the report is sent to the operator that takes charge of booking the needed exams. Finally, the booking data are stored and the file is closed. Nowadays, there are not so comprehensive solutions able to allow the realization of such applications. In fact, to build applications like this, we would need ad hoc implementations of all the necessary ingredients. Some different tools could be used to do part of the work, but in any case, a manual intervention would be needed, at least to merge together the different parts and create the actual orchestration logic. We will see how our solution actually goes beyond the current state of the art, allowing programmers to rapidly develop, deploy and run complex applications mixing people, UIs and services, using a unique paradigm and environment. The key idea of our solution is to split the orchestration problem into intra-page synchronization, that is the synchronization of UI components belonging to a same page, and the orchestration of distributed UIs and services, including the synchronization of UI components placed on different pages and the interaction with standard web services. This is possible thanks to the support given from two separate runtime environments, one completely running inside a client browser and implemented in JavaScript, and the other constituted by a standard service orchestration engine. In our project, we have chosen Beeple as service orchestration language, since it is powerful, widely adopted, and extensible. That said, it is important to make clear that our solution is not strictly related to this technological choice, but conceptually we could replace Beeple with any other service orchestration or workflow management system. This is the architecture of our platform, covering all the three phases of the application lifecycle, that is, design, deployment, and runtime. Time constraints do not allow us to describe it, so we refer you to the BPM paper. Let's start from the development environment of our single orchestration logic. This is the Eclipse Beeple editor that we extended. For 10 reasons, we have already created a new project including all the WSDL files we need, then we have created a new Beeple process and set the imports. It is important to say that also UI components are described through almost standard WSDL files. Okay, let's build the process. First of all, we can create the pages that will include all the UI components. For example, we can start from the page for the operator. The page creation requires, first of all, the specification of the name of the HTML template for the current page. Then we need to define which is the UI engine server in which the page will be deployed, and finally the user that will own this page. Now we can create the partner links for both services and UI components. Let's create first a partner link for the service managing the patient database. In this case, we need just to choose the partner link type, which is related to the WSDL of our service, and the rows of the partner link in this process. This is the usual way to create partner links for standard web services. Now let's see how it's also simple to create a partner link for a UI component, for example for the Google Map. In this case, first we define that we are creating a partner link for a UI component, then we specify the page where the component will be placed, and finally the placeholder inside the page that will contain the component itself. At this point, we just need to set partner link type and roles as we did before. Now we can start putting the activities in the process. For example, we can put an invoke for the patient web service, and in the same way, we can put an invoke for the show point variation of the Google Map UI component. As you can see, in a simple way, we design a little part of our process including both services and UIs. Going ahead, we build the rest, and finally, this is the whole process for our Home Assistance application. Let's move now to the console that developers can use to manage their applications. In particular, from this page, they can automatically compile and deploy them. It's sufficient to upload a zip file containing all the needed files, that is, WSDOS, JavaScript, HTML layouts and configurations. Once we have packaged all these files into a zip, it's enough to upload it clicking on deploy. Now the compilation process generates and properly deploys all the code needed to make the application working. There is the standard Beeple that will be deployed on the Beeple engine, all the needed UI orchestration definitions, and also the mediator services allowing the communication among UI engine client and Beeple engine, which will be deployed on the UI engine server. Well, the compilation report says all is okay. So now we have our application completely deployed and ready to run. Let's go to run it. This is the console for the final users of the applications. Now we log in with the user that is the owner of the operator page. As you can see from this page, we can start a new instance of the Home Assistance application. Every time a new request for assistance arrives, the operator will start a new instance of the process. As we click on Start in the table below, a new active session of the application is shown, and we can work on it. As you can see, this is the page for the operator. First of all, the operator can select the patient. As expected, the patient profile is immediately updated, and from here you can also see the patient location on the map. These are intra-page communication that, as we said, are completely managed inside the client browser. At this point, the operator fills in the data of the request, specifying a description, type of problem, and priority. Now the operator sends these instructions to the assistant. Let's see if these data are there. Now we do the login with the user that is the owner of the assistant page. Here we can join the process instance that was created from the operator, simply clicking on Join. And this is the page for the assistant. After a second, the components are updated. At this point, the assistant physically visits the patient and writes a report, specifying if further exams are needed or not. This report is processed in the Beeple engine, which calls the report archiving web service and, since further exams are actually needed, also sends the report to the operator that will have to book the exams. In fact, going back to the operator page, we can see that the booking component has been updated, and the operator can insert the data of the exams he booked, maybe by phone. These data are then sent to the process that stores them, invoking another dedicated web service. Now the process instance can be actually closed. Concluding in this demonstration, we have seen how our solution makes possible to integrate people, user interfaces and services into a single orchestration logic. We built our solution reusing as much as possible standard languages and solutions, making easier the life of those programmers already familiar with these well-known technologies. Moreover, we have seen how our solution gives the possibility to develop applications in which more people can collaborate working together over the same process. As future works, we plan to introduce the dynamic selection of the actors at development and runtime, and moreover try to simplify the development environment and paradigm to be able to provide your orchestration as a service in a complete hosted fashion. Thank you for your attention.